Hi everyone, welcome to the fourth session of Unit 1 on blockchain and smart contract. This session we are going to talk about blockchain transactions, what they are, why they matter, and how they keep blockchain is secure and decentralized. What is blockchain transaction? Blockchain transactions are the fundamental building blocks of decentralized and secure system. They enable the transfer of value, information, and data between parties in a transparent and immutable manner. The blockchain transaction is a digital record of value, data, or asset transfers between people on a blockchain network. Think of it like a sending money online but without a bank in middle. Instead of relying on a bank or any central authority, blockchain transactions are verified and recorded by a network of computers across the world. This is what makes a blockchain decentralized, transparent, and secure. Now we are going to see about the understanding blockchain transaction. So what are the key components involved in these blockchain transactions? So we can break it down into three simple parts: sender information, receiver information, and transaction amount or data. These elements make a blockchain transactions secure, transparent, and trustworthy. Sender information. This is nothing but who is sending the transaction. The sender is the person or a system that starts the transaction. It could be someone sending cryptocurrency or sharing data on the blockchain. Every sender is linked in a public key. There is nothing but a special code that acts like their digital address on the blockchain. Think of this like a sending an email. Just like we have an email address, the blockchain users have a public key. That is nothing but their wallet address to send transaction. How these blockchain verify the sender? To prevent fraud, blockchain network use digital signatures. How it works? The sender digitally signs the transaction using their private key. The blockchain network checks the signature of the senders by using sender's public key. If everything matches, the transaction is approved. The second one is nothing but a receiver information who is receiving the transaction. The receiver is the person or a system that gets the transaction. Just like a sender, the receiver is identified by a public key or wallet address. Think of this like a receiving money in a bank account. When someone sends you money, it goes to your account number. In blockchain, this is your wallet address. How is the receiver is identified? The receiver's public key, there is nothing but a wallet address, acts as the destination for the transaction. Once the transaction is confirmed, the funds instantly appear in the receiver's wallet. The security tip for receiver: even though the wallet address don't reveal personal information, they are visible on the blockchain. To stay private, some users generate a new wallet address for each transaction. The third component is transaction amount or data. That is nothing but what is being sent. This is the actual value being transferred in the transaction. It can be a money or other types of data. When sending cryptocurrency, the transaction amount specifies how much is being transferred. The value is usually in Bitcoin, Ethereum, or other cryptocurrencies. Non-money transactions, storing data on blockchain. Not all blockchain transactions involve money. Some transactions store important data on the blockchains like supply chain records, medical data, voting system, smart contracts. How blockchain transaction work in a simple step-by-step manner. The first step is an initiation, creating a transaction. Imagine you want to send cryptocurrency or some data using blockchain. The first thing you do is create a transaction. So in this process, you enter a receiver's wallet address, you specify the amount or data you want to send, then you sign it with your private key. This private key generates a digital signature which proves that you are the real owner of the fund or data. Without this signature, the transaction won't be accepted. The second step is broadcasting, sending the transaction to the network. Now, the transaction is not confirmed yet. It needs to be broadcast to the blockchain network. The transaction is sent to the multiple nodes in a network. Each node gets a copy of the transaction and checks if it is legitimate. This ensures that no one can secretly modify or delete the transaction. For example, Ali's transaction is sent to thousands of Bitcoin nodes worldwide. So in this case of a transaction, Alice want to send one Bitcoin to Bob. What she will do initially means she enters the Bob's wallet address and the amount. Then she signs the transaction using her private key. Now the transaction is ready to be sent to the network. Now Ali's transaction is not confirmed yet. It needs to be broadcast to the blockchain network. The third step is validation, checking the transaction for accuracy. Before a transaction is added to the blockchain, it must be verified. So each and every node in a blockchain check if the digital signature is valid. This proves allies really the authorized transaction. Does the allies have enough balance? This prevents double spending. Then is the transaction formatted correctly? This ensures it follows blockchain rules. If any one of these checks fail, the transaction is rejected. If everything is fine, the transaction enter a waiting area called memory pool. For example, if Alice has a 1 BTC in her wallet, the transaction moves forward. Otherwise, it gets discarded. The step 4 is inclusion in a block, the finalizing the transaction. Once the transactions validated, then the transaction need to be added to a block. Here, how it happens means the miners or the validators pick transaction from the memory pool. They group them into a new block. The block must be confirmed by the network through a consensus mechanism. The last step is finalization, making the transaction permanent. Once the block is validated, it is added to the blockchain. The transaction becomes permanent and cannot be changed. The receiver, the Bob, now sees the funds in his wallet. Okay, the key properties of blockchain transaction that make them secure, transparent, and immutable. These properties ensure trust, prevent tampering. So the first key property is immutability. The transaction cannot be altered. Once the transaction is recorded on a blockchain, it cannot be changed, it cannot be deleted or altered. This prevents fraud, manipulation, and double spending. So why the immutability is important means it prevents fraud. Hackers cannot modify faster transaction, and it ensures data integrity used in supply chains, healthcare, and legal records, and increases trust. The user can rely on blockchain as a tamper-proof system. So for example, if Ali sends one BTC to Bob, the transaction is permanently recorded. She cannot recover or modify it later. The second property, transparency, publicly verifiable. The transactions on a public blockchain are visible to everyone. Any user can verify transactions using Block Explorer. Why transparency is important means it prevents corruption. The governments and business cannot hide transactions, enables auditing. Financial transactions can be verified by anyone. It will build trust. The users feel secure knowing all the transactions are publicly recorded. The third property is irreversibility. No chargebacks or reversals. Once the transaction is confirmed and added to the block, it cannot be reversed. This eliminates fraudulent chargebacks, which are common in credit card payments. Why this is important means it prevents fraud. User cannot make a purchase and later dispute it. It ensures transaction finality. Once confirmed, ownership is transferred permanently. Encourages responsible transactions. Users must double check details before sending funds. Fourth one is nothing but security. The strong cryptographic protection. Blockchain transactions are protected using advanced cryptographic techniques, making hacking and unauthorized access nearly impossible. So it protects funds and prevents identity theft and enhances trust among the people. So these properties make a blockchain highly secure, decentralized, and trustworthy, enabling applications in finance, supply chain, healthcare, and identity management. Types of blockchain transactions. The blockchain transactions do much more than just sending money. They enable financial transfers, automate contracts, store data, and even require multiple approvals for security. Let's break down the different types of transactions and how they work. First, monetary transaction, sending digital currency. This is the most common type of blockchain transaction, transferring digital currency like Bitcoin or Ethereum from one person to another. Why this is important means it eliminates the need for banks or middlemen. It allows fast and borderless payment. It ensures transparent transactions, reducing fraud risk. For example, imagine Alice want to send one Bitcoin to Bob. She initiates the transaction, the network verifies it, and once confirmed, Bob receives the fund. Simple, secure, and permanent. The second one is smart contract transactions, self-executing agreements. The smart contracts like digital agreements that execute automatically when conditions are met. These contracts are stored on a blockchain and do not need human interventions. How this works? A smart contract is created with the preset conditions. User interact with the contract by sending transactions. When the conditions are met, the contract executes automatically. The result is recorded on the blockchain, ensuring the transparency. So the importance of this smart contract transaction, it removes the need for intermediary like banks or lawyers. It increases efficiency and eliminate human error. It builds trust because the contract terms are enforced by code. The third one, data transaction, storing information on blockchain. Blockchain is not just for money, it can also store and secure valuable data. These transactions record information like supply chain details, identity verification, and medical records. So the users submit the data to be recorded on the blockchain. The transaction is verified and added to the block. The data remains tamper-proof and can be retrieved when needed. So this prevents the data manipulation and fraud. It enhances transparency in industries like healthcare and logistics. It removes the risk of centralized database hack. The fourth one is multi-signature transactions requiring multiple approvals. Some blockchain transactions require multiple people to approve before they executed. This is called multi-signature transaction and it is used for added security. For this kind of a transaction, a transaction is created that requires multiple signatures. That means that approvals. The required signatures review and approve using their private keys. Once the necessary number of signature is collected, the transaction is executed. Everything is recorded on the blockchain for transparency. So this kind of a transaction enhances security by preventing unauthorized transactions. It ensures agreement among the multiple parties in a business setting and it prevents a single person from having total control over the funds. So the blockchain transactions are changing the way we transfer money, sign contracts, store data, and manage security. So here the money transaction enable fast, secure digital payments. Smart contracts automate agreements without middlemen. Data transaction ensures tamper-proof of record, and multi-signature transactions improve security with multiple approvals. So with the blockchain technology growing fast, these transaction types are shaping industries like finance, governance, healthcare, and supply chain management. So we are going to explore why transactions are the backbone of blockchain technology. Without transactions, the blockchain network wouldn't function effectively. The transactions is nothing but the foundation of blockchain. The transactions are the basic building blocks of blockchain. Each transactions represent a transfer of value or information between the participants. The entire blockchain system is designed to process, validate, and store these transactions in a secure and immutable ledger. Why this is important means the blockchain enables trustless exchanges. Every change is securely recorded. The transactions power smart contracts, tokenization, and decentralized applications. Every time you transfer a Bitcoin, execute a smart contract on Ethereum, or record supply chain data, you are creating a blockchain transaction. The blockchain enables a trustless system, no middleman required. In a traditional system, you need a bank or a third party processors for transactions. But blockchain allows direct peer-to-peer exchange. Instead of bank verifying transaction, a decentralized network of node does the job. This reduces the cost. Transactions are faster. No single entity can block or censor a transaction. Decentralized ledger, secure and reliable transactions. What this means every validated transaction is stored across multiple nodes in a blockchain network. there is a no single point of failure. If some nodes fail, the system still works. The transactions are verified through consensus mechanisms like proof of work or proof of stack. So this prevents data loss or corruption, ensures high security. Transactions can be publicly verified. Okay, what are the applications of blockchain transaction across industries? Blockchain is not just about cryptocurrency, it is transforming multiple industries. First, cryptocurrencies. Blockchain transaction allow fast and secure digital payments. You can send Bitcoin or other tokens anywhere in the world without needing a bank. Second one is called supply chain tracking. You ever wondered how companies ensures their products are genuine? The blockchain transaction store real-time data on goods, ensuring authenticity and transparency. For example, a coffee company tracks its organic beans from farmer to your cup. By scanning a QR code, you can verify the product's journey and ensure it's ethically sourced. Digital identity management. Identity fraud is a huge problem, but blockchain can help. The transactions on blockchain store proof of ownership, certification, and personal credentials. For example, the universities can issue degree on blockchain. This prevents forgery, so employers can verify if someone really earned a degree. In healthcare, the patient's record must be secure, private, and accessible only to authorized personnel. So, blockchain transactions store medical records in a way that ensures both privacy and interoperability. So, finally, the blockchain transactions are revolutionizing industries beyond finance. They provide security, transparency, and efficiency in payment, supply chains, identity management, and healthcare.